So today we're going to take a look at exponents, how exponents work, what they mean. When we look at something like a to the fourth, that really means a multiplied by itself 4 times. So anything like 5 cubed means 5 times 5 times 5 multiplied by itself 3 times, and we know that that gives us 125. Similarly, even if it's a negative 1/3 all cubed, would be a negative 1/3 times a negative 1/3 times another negative 1/3, and you know in multiplying fractions you multiply the top, multiply the bottom, so we get negative 1 over 27. Even negative 1/3 to the fourth means you'd multiply negative 1/3 4 times, you'd multiply the top, multiply the bottom, and we get 1 over 81. Now, I do have a question for you. Does negative 3 squared in parentheses on the right equal the negative 3 squared on the left? Well, on the right, that squared applies to the whole parentheses, so it means negative 3 times negative 3, which would be a positive 9. Now here on the left, that exponent does not apply to the negative, it only applies to the 3. So it really means a 3 times a 3 with a negative in front. Or it really means the opposite of a 3 squared, and we know that 3 squared is 9. The opposite of 9 is negative 9. So on the left we get negative 9, on the right we get 9. So they are not equal. However, if you want this on the right, but you type in what you have on the left on your calculator, you will get the wrong answer. So just be aware of that. So another thing here, does 2 times 3 to the fourth, is that 2 times 81? Or is 2 times 3 to the fourth really 6 to the fourth? So basically, do we do the multiplication first and then do the exponents, or do we do the exponents followed by the multiplication? And when you think of PEMDAS, you have to do the exponents first, then multiplication, so it's really the first one of 162. Then we have pretty much any number raised to the 0 power is 1, with the exception of a 0 raised to the 0. Now, if you would happen to take calculus at some point, you would know 0 to the 0 is referred to as an indeterminate form, which means you can't determine your answer until you do more work. But we're not going to be dealing with any of that in here. So if you ever come across anything to the 0 power, it's just going to be 1 for the sake of our class. Also, as a review, when you're dealing with negative exponents, it just means that the negative exponent gets to move to the other part of the fraction. So right now, a to the negative n is in the top part of a fraction because this is really over 1. Gets moved to the other part, so we go 1 over, and it's going to be a to the positive n. So a negative exponent gets moved to the other part of the fraction, and then the exponent becomes positive. So like 5 to the negative 2 would be 1 over 5 squared, which is 1/25. Or anything like this here. Here we have a negative exponent in the other bottom part of the fraction. It really gets moved to the top part of the fraction then, becoming 8 to the third. So just to review exponents, 5 squared times 5 cubed would be 5 times 5 for your 5 squared, or your 5 cubed, which really means we have 5 multiplied together 5 times. So in other words, 5 to the power times 5 to the power, we really add the exponents, and that's what we're talking about here on the right. Here, we would have, because we're cubing, a 2 to the fourth multiplied by itself 3 times. Now we could use the idea that we just talked about up here, where we'd have to add the exponents, and we would get 2 to the 12th. So what are you really doing to that 4 and the 3 to get the 12? You're multiplying them, and that's what this rule over here is talking about. So here we have 2 to the 5th on top, which means 2 multiplied by itself 5 times. We have 2 squared on the bottom, which is 2 being multiplied by itself twice. And now we have 2 times the top, 2 times the bottom, so this is really a special form of 1. This is a special form of 1. And so all it does is just leave us with this right here, or a 2 cubed. In other words, you're looking at this and you're technically subtracting your exponents. An informal way to look at it is to say, oh, which one has more 2's, the top or the bottom? And the top does how many more? It has 3 more on the top. That's an informal way to look at it. So down below here, we have two things multiplied inside, all cubed. So that would mean a 2x times a 2x times a 2x, which since everything's multiplication, you can multiply in any order you want. So it'd be 2 multiplied by itself 3 times, and then x multiplied by itself 3 times, or a 2 cubed and an x cubed. So when it's multiplication here, really that exponent applies to each part, and that's what this is saying. So for the most part here, we have a negative exponent on top, so it's going to get moved down to the bottom. Here we have a negative exponent on the bottom, it gets moved to the top. So if you have negative exponents on top and bottom, they just switch spots, become positive exponents. Or if you have a fraction that's all raised to a negative power, it just flips that whole fraction, and that's what this is saying. So now let's go ahead and apply this. Now inside our parentheses, it's multiplication between everything. In between the parentheses is multiplication. Everything's multiplication, so we don't really need the parentheses. Now we can go ahead and multiply in any order we want. So I'll put the normal numbers together, then I'll put the A's together, then followed by the B's, since you can multiply in any order you want. Multiply by more normal numbers, I get 10. A to a power times a to a power. We have to add our exponents. This is an a to the first. Here we also have to add the exponents on the b's. If there's no exponents, remember it's a b to the first. So you'd have a 1 plus a 4 to give you that fifth power. Now here you could ask yourself which one has more x's, the top or the bottom. The bottom does, and it has 8 more x's. But because it's on the bottom, you'd have to technically go 1 over that. So here we're cubing. Once again, cubing means you got to take the parentheses and multiply by itself 3 times, which, since it's all multiplication, really means, because if we did that, so everything's multiplication in the parentheses, everything's multiplication outside of the or between the parentheses, so you can multiply in any order you want. So you can put all your negative 3's in front. You get this, a c squared times a c squared times a c squared, which is a c to the sixth. And then multiply all your d's together, which means you got to be adding your exponents, and you get a d to the 15th. Here we have a fraction raised to a negative power, so that negative power just flips your fraction upside down. Now we can apply that exponent to the top, that exponent to the bottom, 3 to the 4th over x to the 4th, so it's an 81 over an x to the 4th. So here you might be able to try these two problems before you go ahead and watch the video. So you might want to pause it and then do these. So at this point, everything's multiplication between the parentheses and inside, so I can multiply in any order I want. So I'll put the two normal numbers together, put my x's together, put my y's together. Now I multiply out the normal numbers, multiply my x's, so I add my exponents, multiply my y's, so I add my exponents. Here, once again, which one has more x's, the top or the bottom? The bottom does, it has 4 more. Technically, when you're dividing, you got to subtract your exponents. So if you go 3 minus 7, it gives you negative 4. That's a negative exponent, so it puts it down on the bottom like this here. But informally, you can ask yourself, well, which one has more x's, top or the bottom? That also works. So here we have an exponent raised to an exponent, so it really means an x cubed times an x cubed times an x cubed times an x cubed times an x cubed, because it's to the 5th power. So you'd have to add all those, so you'd have 3 added together 5 times, which is multiplication is just repeated addition, so you just multiply your exponents and you get 3 to the 15th. Same type of thing kind of works over here. That exponent of 5 on the outside applies to each thing on the inside. Negative 2 multiplied by itself 3 times, or 5 times, would be a negative 32. 2 squared, or I mean x squared multiplied by itself 5 times, you'd have to multiply your exponents on your y's also. So on this one here, we'll go ahead and work this out. We can apply that exponent of 5 to each thing on the inside, or we could simplify what's on the inside and then apply that exponent. It really would not make a difference. It's really a personal choice. If you apply that exponent of 5 to each thing on the inside, we would get this here. So now we get negative 3 to the 5th. Exponent here raised to an exponent, so you multiply your exponents. Down below, an exponent raised to an exponent, so you multiply your exponents. Here you have an exponent raised to an exponent, so you multiply your exponents. Now we can see if we have anything the same top and bottom. And while we do, we happen to have a's on the top, a's on the bottom. Which one has more a's? Well, the bottom does. How many more a's? And that's 5 y's more on the bottom. So nothing else will change.